Good morning, Dr. Golparvar. Welcome to Drastic Summit interview series on construction technology. Um, Today, you are both a entrepreneur with Reconstruct, co-founder of Reconstruct, as well as a professor at the University of Illinois. Can you give a little bit more background on um, how you can balance both and how you entered both?
Thank you, Steve, for the introduction. And please do call me Monty. Yes, I do have two things that I do on a daily basis. So I basically wear two hats. At Reconstruct, I'm the co-founder, and currently I'm also the chief technology officer. At the University of Illinois, I'm an associate professor of civil and environmental engineering with background in computer vision and entrepreneurship. So what I do and what I've been engaged with over the past decade is conducting research and development in terms of bringing artificial intelligence to construction engineering and management. Some of the work that I've done have matured enough that they were ready to be commercialized. So Reconstruct is one of those examples. It gives me a pleasure to be wearing these two hats because it brings me the opportunity of being engaged in cutting edge research at the campus level, and also at the same time engagement with Reconstruct make sure that my work has relevance. So now I can balance rigor and relevance at the same time.
Excellent, excellent. Can you give a little bit of background about how you grew up and how you developed your passion for both construction as well as technology?
Absolutely. I was born into a construction family. My father used to be a contractor from time to time. He was a mechanical contractor. And from early days of my life, I was really fascinated by design, engineering, and to some degree construction. When I was, in my middle school age, my older brother decided to get engaged in computer programming. He was programming with mainframes, and this was in early days that mainframes were coming out in oil and gas industry, and I was really fascinated by that work too. So in early days, I started learning about operating systems, started learning about programming languages back then, GW Basic, Pascal, and things of that nature. And throughout my journey of middle school and high school, I always went back and forth between my passion for building infrastructure and buildings, at the same time my passion for technology. So when I was at the college age, I decided to formally pursue a college degree in civil engineering. Perhaps at the time, my desire to civil engineering was motivated by level of readiness for technology and what I had already, learned in terms of programming skills. But again, throughout my undergraduate degree, I went back and forth between mostly programming and software engineering. I won't really call it computer science yet, and civil engineering, and that led me into another master's degree by being passionate about simulating engineering operations in a computer environment before we hit the reality and figure out if there are issues that are going to happen to any of our sites. And then throughout my graduate degree, I moved to Vancouver, Canada, and for some time I was engaged in building information modeling in more formal ways. These were in early years that people were still passionate about measuring ROI and what it means to use BIM for design development, for value engineering, for pre-construction coordination. That was really exciting for me. But at the same time, I realized that, there's really three elements to bringing technology into construction: the product piece, the process piece, which I was really, exercising and learning about, and how organizations need to evolve to sort of adopt and adapt these types of technologies. So I decided to pursue the path of product. I came to University of Illinois as a graduate student, and I decided to pursue two degrees at the same time, doing my PhD in civil engineering and also doing a master's in computer science. I took 95 credit hours, almost doing computer science from scratch again. And I evolved myself into who I am today, who lives at the interface of civil engineering and specifically artificial intelligence by exploring what is the latest in AI and contributing to that body of knowledge with a specific application being construction.
Excellent, excellent. There's many problems associated with the construction industry. You mentioned low ROI, shortage of labor, and it seems that we have gone from something that used to be complicated, where humans could think through and do, to something that is complex, where there's so many variables, a human cannot keep them all straight. You mentioned the leveraging of computers and AI. Can you talk a little bit how Reconstruct got its birth?
Absolutely. You know, throughout my education, I was always working. I started in oil and gas, then I eventually moved to infrastructure projects, and I sort of graduated with commercial building sector. This is at the time I was working for Turner Construction, and I was engaged in construction of commercial buildings. Throughout this process, I learned about the value of BIM and its contribution toward the design, but this was not really being used for construction purposes. When I started, practicing in the field, I realized that, we are facing quite a few problems associated with how we plan our projects, how we monitor that performance, and how we come up with control strategies that can keep our projects on schedule and on budget. There were four specific problems that I learned while I was actually practicing construction. Number one problem that I really realized in early years was, not being able to plan the works properly. As an industry, we've significantly advanced our body of knowledge in terms of how plans and schedules can be created. But when it comes to really getting the data that we need to create reliable schedules, there's a huge room for improvement. I did face lean construction practices, but I realized that these great practices do require champions to be able to properly execute them and make sure that people will not revert back to traditional control strategies that they've had on their projects. The second problem that I really realized was, while we create these plans, it is not always easy to work the plan. There are many reasons why, plans may not be worked as created. Work plans continuously change. Work areas are often not available, and handoff doesn't happen properly across different subcontractors. Sometimes we underestimate work, and of course, we have inclement weather days being in the Midwest. And the last problem that was really the third problem. I'm saying last problem. The third problem was really the communication problem. This was a problem that I was facing myself in my day-to-day work. In some point in my life, I was in charge of processing daily construction reports, and many students who graduate with civil engineering, that's one of the first jobs that they do. So I used to collect all these papers that subcontractors were providing to us in terms of how much work they do, what are the resources that they've had on the job site, and I used to compile them to generate reports. Oftentimes, myself and many of my colleagues who used to work for these construction companies didn't really have opportunity to go into the field and verify if the information that we're getting is really correct. So nobody was really trusting this data. This was more reporting requirement by the owner. So we used to wait for an entire week to get into a coordination room, oftentimes in a trailer, and ask subcontractors to stand up and color code every single 2D drawing that we had. So essentially from the time that the problem was happening to the time that we were learning about the problem, we've lost 1 week of work. Now in the type of projects I was involved in, it was, let's say $20 million to $100 million project. These are, decent sized projects, but maybe the problem doesn't manifest itself because, often we only have 20, 30 contractors, but, scale this up to projects like Inglewood Stadium or projects like Sacramento Kings in California that I had the opportunity of being engaged with. And, the problem scales up because you have 700 workers and there are many trades that are working on the job site and not everybody's on the same page in terms of how much work gets done. And last problem was really bringing this notion of what really happens in the field back into the plan. Every project has a plan, every project has a schedule, but oftentimes people who are revising these schedules are not on the job site. So from the time that the problem happens to the time that that information gets communicated back to the plan, there's always a delay. So we are always missing this feedback loop on how we can use the data to improve the base of plan. So, in the context of these problems that I described in planning and monitoring the work, I was really passionate about how can I solve this problem, not only for myself, but for the companies that I'm working with. For example, when I was at Turner Construction, every year we had around 1,500 projects. Every project, there was somebody like me, or maybe a few, that were processing this paperwork. And, so scale this up in terms of how much we are putting into the resources on the job site to process the data, and looking to the efficiency that is associated with the process, or rather inefficiency. So my interest was to solve this problem in a way that everyone who's on the job site would be able to leverage the data. And my passion on BIM obviously led me to think that, there's value in this, right? In this 3D modeling that we do in design, development, and coordination. Can I figure out a way that I can integrate that to the schedule that the superintendent has on the job site, so we can generate a reliable basis for rather production tracking in the job site? On the other hand, I was really fascinated by pictures. You take a picture and you show it to every contractor who's on the job site. They immediately understand how much work has been done, what are the areas that are at risk, what are the quality issues, and what are the safety issues. Now, when I started, being passionate about photography on job sites, people used to fly helicopters on job sites maybe once a month and taking some pictures. And by the time I was, practicing work at Turner Construction, we just had started looking to time-lapse photography. And digital cameras were just coming out, cameras that were at 2 or 3 megapixels at most, contrasting to today where we get 20 megapixel cameras for just a few $100 easily, or even in our cell phones, right? So I was really passionate to figure out how I can use the power of pictures that really speak the source of truth on the job site, contrast them against the design that is in 3D with all the information that is embedded in it, so I can make sure everybody's on the same page. If I can visualize design over the reality of the job site, you can always contrast the delta between the two. And no matter if you're the owner, if you're the contractor, you're the sub, or maybe the insurance company that's not even on the job site, you'd be able to make sure everybody's on the same page in terms of how much work has been done, what are the problematic areas, what is the risk in project execution, and what are the opportunities to be that we have to address this. So I got engaged in this study of computer science, specifically on AI, and within AI, computer vision, which is the study of images and videos, on how I can tap into this wealth of information that we already have on our job sites and figure out I can address the problem without adding new work or require more work to be done for addressing this problem of monitoring and control. So it was initially a prototype. We piloted that prototype at Sacramento Kings Stadium, which I referred to earlier. We were fortunate enough that Turner Construction gave us an innovation award for the year on that project. We presented the work at World Economic Forum. We got another innovation award from the Construction Roundtable, and we got immediate interest from construction companies that wanted to start using it. What we all had was just a prototype. And that's basically what we do at university. We validate or we prove the concept, and beyond that is really not what we pursue at the university. But with my passion and my interest in solving the problem that I used to face myself on the job site, I thought we need to start a company that can transform the prototype into a solution that industry can really use on a day-to-day basis, and the solution would be sustained. So we started a company with almost a team of 2, and the company has grown to a team of more than 40 people across multiple offices and hundreds of projects in the US, Europe, Asia, Australia. And now I have the opportunity of seeing different types of practices, and I have a better vision into where the problems are at the scale.
Excellent, excellent. Can you talk about the different technologies that converged into your solution? You mentioned AI, you mentioned photography, photogrammetry, and then you also mentioned BIM and overlaying reality to what it's supposed to do. Can you talk a little bit about the technologies?
Yes, absolutely. I will put it in very simple terms. Imagine a picture of a job site. Imagine a picture that shows you concrete operations just finished. So we have a few foundation walls that perhaps are complete, and we've been able to capture that through a photograph. And then imagine a 3D model that shows us the entire scope of the concrete work that is expected to be done, including all the foundation work, all the columns that we need to put in place, and the superstructure that goes on top of it. Imagine a mechanism by which you can visualize that 3D design that shows the concrete structure only with respect to what was promised to be done according to the schedule to that day, superimposed over the photograph. So it's almost like augmented reality, a picture being augmented with a three-dimensional model that simply shows what was the promise that we made on the job site. Now, contrasting that model against a picture can help us color code the model in very simple ways using metaphor of traffic light colors. So if there are areas that are on the schedule, your model will be shown in green. And if there are areas that are problematic or at risk of being delayed, it will be shown in orange and red. So now you would have a spectrum of colors that can easily show you where the problems are. So if you're an owner and you happen to be in Toronto and your project happens to be in Midwest, now you can look into this photograph that perhaps will be popping up on your web browser, and you can immediately see where the problems are. So you don't need to travel to the job site, and you can proactively help addressing these problems before they escalate into delays and cost overruns. And with COVID-19, you can imagine the value of this. You no longer need to be really on the job site. You can enable remote monitoring of quality and progress at leisure of sitting at your home office.
And that's really amazing because you have one source of truth. And that one source of truth can be viewed by everybody, safety, the owner, the superintendent. So everyone is literally on the same page. How can it also be used for safety certification to make sure that proper safety procedures are being done on the job site?
Absolutely. Because my interest has always evolved around solving this problem of monitoring and bringing the feedback from the field, I have mostly focused on progress and quality at the commercial grade. But of course, there's a lot of things that could be done on the safety side, some of which are direct application of this type of a solution, and some of which are more elements of research that I'm conducting in safety. Safety is, of course, the most important factor on every one of our job sites. And scaling that up, unfortunately, we are losing almost 4 lives every day in the US on our job sites because of exposure to openings that people are falling because of equipment's backing up and workers are not informed, perhaps they're in a blind spot, and a few other issues that OSHA has always been listing. So in the context of that, there are a few things that can immediately be done with this type of visual data. One, you can always plan for safe operations because we have the BIM model, because we have the schedule. We can always visualize the sequence of the work that is expected to be done by various trades in the context of the reality, the picture. So you can actually see where your scaffolding is placed, where your temporary structure is located, and see what is the sequence of the work and what is sort of this period of trade you're going to see on the job site. So if you can see that and communicate that and coordinate that with your subs in your toolbox meeting, in your weekly coordination meeting, then you have an opportunity of preventing it through a plan. Now, let's imagine we've already done that and we get into the execution phase. Of course, we always have people on the job site that are always in charge of safety, but if you want to do a safety inspection, oftentimes we also bring in regional safety inspectors. Many companies in the Midwest, as an example, they only have one or a few regional safety inspectors that they visit job sites once a month. So what this technology can do for them is to provide them with an ability to perform a virtual and visual walkthrough on the job site. think of Google Street View, right? Everybody's used Google Maps. Imagine yourself, you're walking between these pictures, you can measure them, you can annotate them for all kinds of safety issues that you see. So now we can significantly improve um, frequency of safety documentation and make sure we tap into the expertise of these regional inspectors at a scale across all of our projects. Now, in the context of research, the visual data that we capture provide us with a tremendous amount of opportunity. One of which is immediately being able to detect, personal protective equipment for the workers. So almost like 7, 8 years ago, we conducted some research in automatically helping detecting safety gear and providing feedback to the workers and the foremen to make sure we can prevent problems by helping everyone be educated on how we can prevent safety through PPE. And then we started scaling that up by thinking that, well, a lot of safety problems happen in the context of the work. So what if we really try to figure out what is it that the worker is trying to do from a video, maybe from an image, and see if we can potentially provide feedback for improving the basis of safety or even occupational health. It could be as simple as a body posture. So we started working on a body of computer vision algorithms that can track motion of workers in the context of pictures and videos to see if we can actually help them be educated on what are the best sequence of body posture that can keep them healthy and safe during their work. Or if they're using tools and they're not using them according to the guidelines that we wanted to use them, is there an opportunity for us to provide that type of feedback? Last summer, we had an opportunity of working with Nvidia on project. Nvidia is a company that produces graphic cards. They provide us with some grant, and one of my students was also interning at Nvidia. And Nvidia was also passionate about construction. Why? They were actually building their own new headquarters in California. So we teamed up with the technology team, AI team, and mostly the GPU team at Nvidia. And on our side, we were trying to figure out how we can provide them with the support on the safety side. So what we did is we came up with a body of algorithms that not only detect and track workers, but they would forecast the motion trajectory of the worker in the next few seconds. And what we did that was, basically using videos that are being streamed live into our servers and being processed. So in real time, we would be able to predict where the worker is likely going to move to. Now, for the audience who's listening to this conversation, Steve, that you and I are having today, I'm thinking, they've probably seen maybe new vehicles, cars that they actually have pedestrian detection capability. Maybe they've seen ads. There's a body of these vehicles. Volvo has them, Audi has them, and many American cars also have started introducing this type of technology. So what we can do is to imagine that this type of camera can be sitting on our construction equipment, can be sitting on most informative videos on the job site. So we can make sure that the workers are not going to be walking into unsafe areas. And now we have that prototype. So we do have the ability to scale that up into another commercial solution.
That is outstanding. You mentioned the proactive nature of it. Your current reconstruct looks at the past and what it should be. Are you doing work on the predictive and on the pace of work and the predictive nature going forward? Can you talk a little bit about that?
Absolutely. So, when we started creating these visuals that were simply being color-coded in green and red, that was already significant contribution to how work was being done in coordination. But, we got feedback that, hey, it would be really nice if you can really understand what are the problems that are at risk, what are the locations on the job site that are at risk of potential delays. So when we go into the coordination meeting, we can proactively discuss them and figure out how we can create a more reliable look-ahead plan for the next few weeks. So we started working on algorithms that would analyze the trend of production, the amount of work that every sub does on the job site every day, and also their productivity when we get access to manpower information, and see if we can actually model how patterns of production and productivity change throughout the day, throughout the week, and throughout the entire project. If we can create models that can learn automatically from the data, then we can actually use them to infer the potential rates of these productions and productivity in the future. So with that in mind, we tapped into these look-ahead schedules. We created a number of new algorithms that can forecast these productions and productivity rate, and we would contrast them against the plan. If we see there's a deviation between what was promised versus what is really happening on the job site, we can alert the project team on locations that, hey, we realize there are some ongoing activities. We feel like this location is going to be at risk. Or there are going to be a few activities you plan on starting next week. But with the current rate you have on the job site, we can almost certainly guarantee that you're not going to be able to start them on time. So we started color coding these locations, and we took them to a few jobs. One job site in Chicago, and the project team started using them in coordination meetings. It took almost about 6 weeks for the project team to really get into a new workflow, that as opposed to just going around the room and calling companies, hey, company A, company B, company C, how much work you've done, what is it you guys plan on doing. We would focus on locations. Imagine you go into this room and you say, hey guys, this is location that I have on the job site, let's say podium deck for a hotel structure. And this location is at risk of being delayed. Who's going to be working on this location over the next 2 weeks? So now you catch attention of a few companies that plan to work in that location. What are you guys going to do to improve your work, so we will not be facing this risk as being anticipated? It completely transforms the way we approach coordination. And I wish I was able to share some of these videos, some of them on our website. It was really eye-opening. We started realizing that some of the subs now in these meetings are proactively participating in conversation. Why? Because not only the delay that has always been discussed is impacting the project, it is going to be impacting their own bottom line. So now you've aligned their own incentive with the project incentive. And now they can be participating in this conversation and say, hey, I'm going to be mobilizing my crew into the other location, so I get that work done. When these guys are finished with the work that's been left here, I'm going to go back and finish that work. So now we maximize everyone's productivity. It's been really eye-opening. When we see subs that were not really tech savvy are standing up and they're interacting with all this visual data in a meeting, and they don't need to really call it BIM or virtual design and construction. This is just a picture, and it's a single source of truth that shows you where the problems are, and all you're doing is you're trying to figure out how you can prevent it from happening.
Mani, can you talk a little bit? This sounds fantastic. It sounds like it's being adopted. It sounds like there's appears to be savings. Can you talk some actual numbers? Can you talk some success stories so the audience has a feel for the magnitude of what it can do for them?
Absolutely. This platform that I described to you, Reconstruct, supports 3 different workflows. One is pure visual documentation and ability to have a street view experience of walking between photos. The second one is this notion of providing a visual that shows you what is there versus what should be there, which supports quality control. And the last piece is when we visualize this in the context of the schedule. So now you can actually perform your progress monitoring and forecast the risk. So I'm going to describe 3 case studies perhaps that relate to these 3 different workflows. Starting with the last one on the progress monitoring part, which is a project that I mentioned earlier. On this project, over a 6 weeks time frame, we were able to take the team from a PPC of roughly around 45-46% to 70%. PPC refers to percent plan complete, and that's a metric that we use to define how much work is being planned to be executed and how much of that really gets done. We were also able to track how many times tasks are being delayed or how many times tasks are being repeated. When people create these look-ahead plans, oftentimes we don't even get to start them. So we have to bring them back to the next set of plans that we create from the following week. So we're able to use these metrics to measure the impact of a visual production management system for preventing delays and bringing more stability to the schedule. The second case study we performed was really using this entire workflow at the entire project level. So, the first project was a short period of time, it was more focused study, but this time we really wanted to make sure that we can analyze the impact of this system end to end. And these type of analysis will take a long time because we have to wait for the entire project to start and finish so we can analyze the data across the entire project. So over a period of 12 months, we monitored a number of metrics, one of which was acceleration in the schedule. So the project was about 12 months. It was rather, small, medium-sized project in Georgia. And the project ended up finishing 4 weeks ahead of schedule. So we were able to shave off 1 month out of the 12 months of schedule, which is, a substantial amount of improvement considering a lot of practices that we see today. And as much as we were contributing to the project, a lot of different personas on the job site, including superintendents, they were more passionate about or interested about understanding how it helps them as much as it helps the project. So if you've been in the superintendent shoe, I have, and if you've interacted with foreman, one of their pain points every day is they have to basically chase subs to understand how much work has been done and get them to file the reports that is required by the owner and to understand it. So we also wanted to see if we can save time associated with how progress is being documented. Now at Reconstruct, there's a mobile interface that runs on iPhones and Android devices that people are using to communicate back to this visual production management system. And it's mostly voice activated. All you need to do is you speak to it, and whatever you say will be automatically transcribed from voice to text. And people love it. You no longer need to even type anything, right? I mean, it's completely automated. Just, even if you forget, when you're driving back in your truck, just, call in and record your voice, you're done. You've already created that recording. We were able to show that we saved roughly around 30% of the time that the superintendent roughly used to spend on, getting this type of information versus making it completely data-driven and automated. Now, on the what is there versus what should be there, one of the metrics that we wanted to use was change orders. Many projects face change orders and RFIs. And one of the interests that this company had was to look into change orders that are mostly coming from the subs. And what that means is that design has not been properly coordinated, or when it's issued for construction, it's not properly vetted for means and method that the subcontractor wants to account for. Now, being able to visualize what is expected to be done against that reality provides an opportunity to make sure everybody's on the same page in terms of what needs to be done. This is the first job site for this contractor that there was a zero change order created by the subs, zero. And that's a huge saving, not only for the contractor, depending on what kind of contract they have, but also for the owner. You're preventing these types of reworks and problems from happening. And last one was really the ability to monitor work remotely. This is before COVID-19, this project, and the project had a few key executives that are not in Georgia, so they had to commute to the job site, typically twice a week. And the commute was around 2 hours of work. We were able to shave off another 50% time from traveling to the job site because, again, you'll be logging into a web-based environment. You don't need to install any software. All you do is you put your username and password, and you immediately see what's happening on the site. You can annotate it, send a text message to someone, and get your work done. The last case study I want to refer to is a little bit different from the first two. It's mostly around the first workflow that I described, the visual documentation. When we started Reconstruct, we used to see a lot of drone pictures, and for indoors, we used to see a lot of laser scanning being done. Laser scanning is a great way of capturing reality, but oftentimes it tends to be expensive and does require people to be operating that device. So when you want to perform quick and easy documentation of the job site, you may default back into just taking photos. Because we have the ability to analyze videos and transform them using these computer vision algorithms into models, companies were interested in complementing their indoor capturing capability with our reality mapping, not just capturing it, but actually mapping it in a three-dimensional environment. So we worked with a company on a process plant type structure. So it was some module that is typical in pharmaceutical industry, it's typical in oil and gas, and you would send people to perform a scanning. This applies to both greenfield and brownfield projects. And we wanted to really assess how much time it takes to perform the scan, how much time it takes for you to download the data, clean up the data, upload it into a system, process it before it's ready to be shared with the project team. And repeat that process with a video to reality model workflow. On that example, on a few scans that were done, I think scans were close to about 10, 12. The saving was roughly around 9 times associated with how the full-time employees are spending time on this type of workflow. And the cost saving was roughly in the order of 15 to 16 times, because instead of using your scanning device, you're defaulting to a, let's say, 360 camera that would cost you around 400 to 700 bucks at most, with all the gadgets that would go with it.
That is amazing. And are these case studies actually documented on your website?
Yes, I only mentioned about 3 of them, but there's quite a few more. For example, there's another one. We worked with an owner rep on a very large commercial project in California in order of billions of dollars. And that case study shows how this also supports payment application and billing verification process. And yes, they're all available for download. And I encourage everyone who's interested to check our website at reconstructing.com and download these case studies.
Excellent, excellent. You mentioned COVID-19 and the fact that what used to be kind of out of the norm is now the quote unquote new norm, and people are finding it to be so much more efficient. Um, how do you see this benefiting or accelerating Reconstruct and its introduction into kind of the norm of the construction phase, as opposed to, oh, this is a new technology, let's try it?
Yeah, it's as much as COVID has hit all of us really hard on the social side and the financial side. It has also brought a new opportunity to the entire construction industry. And for the first time in many years, many companies are realizing the value of software as a service. And software as a service, I'm dominantly referring to web-based systems that anyone from anywhere can log into the project and get access to a common data environment where everyone would be able to support their design, construction, or even operation workflows. So obviously, our platform being a progress monitoring solution, we got a huge amount of interest in people that wanted to figure out how much work can be done remotely without having people, basically boots on the ground. We supported many project teams on onboarding, the process of documenting their sites with 360 videos and creating these sort of street view experiences, both for indoors and outdoors. So now if they're monitoring their progress, if they want to perform quality inspection, or we had a conversation about safety, they can actually perform that remotely without being on the job site. So we've seen a lot of interest in this type of solution. Now, there are a few other solutions in this space that provide capture capability. One novelty here is the ability to map as opposed to capture. What I mean by that is the entire environment is in 3D and it's measurable. So when you can measure off of a picture, then you can perform a lot of standard engineering construction workflows that you always perform on the job site. And they don't need to be physically there. So this was one interest. But the other interest has been kind of interesting. We started receiving requests for, supporting those companies that want to reopen their offices. And, reopening comes with a few challenges. The question is, do we need to make any changes to the existing layout that we had for our commercial space? Do we need to make changes to our office space by adding new partitions, components, separating chairs and whatnot, so we can make sure that people are going back into a safe environment? Now, in the context of that, if you want to perform improvement, you need your blueprint, you need your plan, so you can actually make those changes. And oftentimes, for many existing buildings, these plans don't exist. So one of the things that Reconstruct does is, if you use the 360 camera for indoors, not only provides a 3D model, but it also provides a 2D floor plan, that is in color, and it shows you exactly where you have your furniture and interior components laid out against that plan. So what we do is we offer that, and oftentimes we see people actually use that in the context of their design environment, so they can, play discs around people, and let's say we want to be enforcing the social distancing in terms of distributing people in space. We want to change the way we walk around the space if this happens to be a retail space, and things of that nature. So this has also become extremely attractive, not only in the context of reopening, but we've had the opportunity of also supporting, cases where existing commercial spaces are being transformed into temporary hospitals for accommodating patients that are being impacted by COVID.
So what's really interesting is you mentioned Nvidia coming up with an extension to what you were doing, the predictive path. Are there any stories that you have that a customer asked you for something and it's like, wow, that's really an interesting use for the technology? You just mentioned about the repositioning of office furniture for safe distancing. Are there any other unique customer requests that's like, wow, that's a really unique way to use the tool?
Absolutely. Thank you for asking that question, Steve. This is one of the most beautiful things about wearing two hats at the same time, meaning the university hat and Reconstruct hat, because through Reconstruct, I get exposed to these problems that if I did not have the opportunity of being part of Reconstruct, I would have never been exposed to. So I want to give a few examples on that. For the interest of conversation we had on progress monitoring, on the visuals that we create for assessing risk and predicting where the problems are likely going to happen. So, that actually came from a request that customers had. They said, it's good to know what has happened in the past, but can you tell us where the problems are likely going to be in the future? Well, once we started rolling that out, we realized that people are coming back to us and, or we go to meetings and realize that while this actionable insight is in front of them, a lot of project teams just still need hand-holding in terms of, now we see the risk, now what are we supposed to do to mitigate that risk from happening? So what they're asking us to do is to say, can you come up with a recommendation on how the plan should be revised based on these patterns that you've seen, so we can provide, let's say, the top 5 recommendations from Reconstruct that you guys should be working on these things, or you can consider them as part of your coordination meeting. Now, this is not commercially available yet, but we've been working on quite a few capabilities on analyzing schedules, not only identifying risk, but now automatically making suggestions as to how schedule should be revised based on patterns that we've seen and based on best practices across many projects. So I started a new work with one of my students who has actually been interning at Autodesk a lot lately to figure out how we can tap into wealth of schedule information that's been accumulated over hundreds of projects every year. And you talk to construction companies that are coming up with these problems, they have thousands of these schedules because they've been accumulating over time. So we can actually analyze them, identify best practices automatically, capture that, and use that to provide recommendations. So we've been working on these algorithms, and this is one of the best opportunities. Now I'm working on something that I'm really passionate about because it involves creating new machine learning based algorithms, and at the same time it solves a real problem, a problem that people would be happy to see coming out in the industry. So this balance is what makes this work that I do every day beautiful.
And you really know you hit on something great when your customers say, oh my gosh, I could use this tool for this. An unintended use for it because of, like you say, a safe source of data, a safe source of information, a single truth. It has many applications. And I think that as you keep going, you're going to find more and more of these opportunities. So are there any more things you're looking at? Where's the future of Reconstruct from a technology standpoint? and maybe even from a growth standpoint, and where are you going to take it as a business?
Absolutely. Um, I mean, there are two parts to it. One, what the industry can do with this type of a solution that we offer, the reality mapping and the visual command center that visualizes the digital twin in the context of the schedule. And the other part has to do with the technology. Let me stay on the first one. What we've realized is, there are always, first adopters across the industry, and even within those first adopters, or every company you pick, there are some projects that are always at the cutting edge of technology, and there are other projects that would require handholding. So what we've done is we've actually mapped out a journey for project teams that we work with them on assessing where they are in terms of their level of readiness to use technology, and we make recommendation of how to get us started with Reconstruct. And it will be really, really simple. For most project teams, they can immediately get started with a reality capture piece, which is just about taking pictures and videos and benefiting from many things that we discussed so far. When they're ready, we'll take them into this process of mapping the reality in 3D. So now they can get used to this notion of measuring, communicating, and documenting issues, mapping that against the design. So now we can actually use that for quality control. This is completely new for many project teams. And even, tapping into the schedule. For many years, the schedule has always been sitting aside from design or, visual data we have on the job site. So basically, we'll take into this journey of reality mapping to the digital twin that shows what is there versus what should be there, all the way to actionable insight that we can offer on progress, productivity, and some of the other metrics that we've discussed. So this is what we're really excited about, and now we can support all kinds of project teams, no matter how ready they are to use the platform. We started with construction management companies, general contractors, and over the past year, we've also seen a huge surge of owners and insurance companies that are now interested in using our solution. So we've also been working on how data can be presented in a form that is catering that type of audience. Not everyone needs to see every single detail that happens on the job site. Some people want to have a high level understanding of the site. Some are more looking into it from a liability perspective. So we've been working on adding these new views to the same type of data. Now, on the technology side of it, there are many things that we're working on, but one thing that is happening today is the partnership that we have at Oracle. So almost 2.5 years ago, we had the opportunity of joining Oracle in their accelerator program. And for those who may not know this program, it's a program that helps startups at the earliest stages to scale up. And as part of this program, we competed with some 380 companies, and we had a fortune of being selected. And with the partnership of Oracle, we've interfaced with many other solution providers. In earlier years, of this partnership, I realized that people often come and say, "Hey, we are working on these large data center projects, and we love this type of visual data capture capability, but can you automate it? We don't even want to have somebody wearing the camera over their hard hat and do the documentation. Can you use a ground robot?" I never thought that this would be a feedback that I would receive from the industry, before, I don't know, 2025. I was always passionate about, robotic platforms. I don't do hardware. But I was, thinking, okay, well, there's going to be a cost associated to this. So let's figure out what is the form factor of this robot that we can bring to enable the type of capture. So we worked on a prototype that places the 360 camera on a really cool robotic platform that acts like Roomba. For those people who use the vacuum cleaning device Roomba, it moves around your room and it cleans it up. So the thinking was the same. What if you place this on a job site after 5 p.m. when the workers are out? It would go around the job site. We can train that to our learning algorithms. So it would repeat that path over and over, and it would take the pictures that we need for all these actionable insights that we want to be generating. So when we started, this was purely a prototype, and I mentioned about Oracle partnership because this platform is available for live demo at Oracle Industries Innovation Lab in Chicago. So a lot of companies come in and they actually see this live, moving around and doing documentation. And then Boston Dynamics lately also joined one of the partners of Oracle Innovation Lab, and we've also worked with them in terms of bringing their data into the platform. It's a really cool platform, and I'm really excited to see this much interest in robotic platforms. Again, perhaps one of the opportunities here is not only there's an interest in improving some of the productivity issues that we have, but COVID-19. Whatever we can do to minimize exposure for workers to things that are happening on the job site, that would be a huge improvement to occupational health, safety, and productivity. So in the context of that, I think this has been extremely helpful to us in terms of working on the next step of autonomous data capture that supports automated progress, monitoring, and predictive analytics.
Do you see the end output when the job is done, that file being turned over to the owner such that they have complete documentation of the construction site from the very beginning for maintenance purposes, for remodeling purposes, and so on? Is that being done today?
Absolutely. Though I wish I would have seen it at a larger scale, but yes, this is happening. Many project teams request the data to be kept in the system. Some request it for 3 years, some request it for 5 years. And then, from time to time, we see really avant-gardist owners that are asking the data to be, tagged with asset information so they can actually use it for operation and maintenance or preventive maintenance down the road. There's less of that. There's more of just making sure the data is there. So, if we want to come back into this room and, perform a drilling into the wall, exactly we know what type of, MEP systems we have in different locations by, doing this sort of time travel and finding the relevant pictures for us. So we see a lot of that. And, going beyond the immediate construction projects, we've also seen an inbound request for supporting inspection. So in fact, over the past maybe 12 months, we've supported hundreds of inspection works and inspection of bridges, tunnels, infrastructure assets, or even cooling towers that you would see on sites. So people are really interested to see how they can also use this data to support that type of inspection we always perform and prevent failures from happening. One of the greatest organizations that we work with is the Ministry of Land, Transport, Infrastructure, and Culture in the country of Japan. This is equivalent of Department of Transportation, or let's say Federal Highway Administration here in the US. And we work with them on creating a journey that we can take people from today's practices of bridge and infrastructure inspection to be completely driven by visual data, and dominantly the visual data being captured by drones. So now Reconstruct is part of the workflow that is defined as the standard in the entire country of Japan on how robotic platforms generally can be used for inspection of robots. We love to see that growing more and more here in the US. We do work with a few organizations that are about to scale right now, but the Japanese, came with this interest, with this vision, and we're very happy to see them work with us to scale our platform. So now we can also support operational maintenance in a way that matters to people.
Excellent, excellent. More and more city centers are being repurposed. Do you see or have you seen interest from people who are repurposing or doing major renovation on buildings for the Reconstruct product, or is it greenfield only?
No, actually, we do see that interest a lot too. Oftentimes the request is about the mapping piece, because they move into this space and they realize, well, they don't really have anything to start their design. Or, they're performing a tenant improvements, and this is a project pursuit. They want to come up with a, quick proposal on what is the change that they want to recommend to the owner. So we support that a lot, where people quickly walk around with 360 cameras, and they capture these point clouds or 2D floor plans, and then they bring it back into the design environment and use that as a base of improvement. For some, the workflow of design is entirely in 3D. This is mostly for oil and gas MEP modules that are really being mapped in 3D. And if it's more of a small to medium-sized commercial space or even residential space, that 2D color floor plan is more than enough. We can bring that back and use that as a base of design. So we see that a lot. But our platform gets used hand in hand with a model authoring environment or design software, typically for Autodesk, Bentley, and the like, or Aviva. And so basically what we do is we support the basis of how that retrofit or renovation can be made. In that workflow, you see need to trace your new design against the reality that we've mapped. And oftentimes I hear people coming and saying, hey, can you automate that process? Which, in academic terms, we call that scan to BIM, which is transforming the point cloud data automatically into a meaningful CAD, a CAD that actually has information that is behind it. And I've had the pleasure of working with one of my PhD students on this topic for almost 6 years now. And we have solutions that can automatically detect MEP modules that are proximity of structure components. So if you have, let's say, a renovation job and you have false ceilings and you want to pop them up and map out your MEP systems, if you use a solution like Reconstruct, you can map it out, use that directly as a base of design, or if you want to take the extra step, then you can work with us through the university research that we have, so we can automatically color code that point clouds and say, hey, we recognize these pipes, connections, and these are the structural and architectural modules that we see from the point cloud data.
It really it seems like things are accelerating. The benefits, we live in an exponential world, and these type of technologies are accelerating on an exponential as well. I want to be cognizant of time here. Is there any question I haven't asked you that you would like to say, hey, Steve, would you please ask this question because you want to make a point? Did I miss anything?
No, I think this was great. Perhaps I can share my contact information if somebody wants to contact me to know how to get us started with Reconstruct, or work with us on the research projects we do on campus.
Excellent, Mani. Reconstruct.com, correct?
Yes, so my email address is Mani, M-A-N-I, at reconstructinc.com. If you have interest in joining us in this journey of going from reality capture to mapping to digital twins to schedule integration, we'd love to work with you to take you from where your project teams are to this solution that hopefully would add value to your existing operations. If you have interest in anything that I mentioned in terms of research and you want to see demos, I'd be happy to connect with you and show those capabilities to you as well.
Excellent, excellent. Well, thank you very much. The Drastic team appreciates your time and your insights into this amazing field and the potential of what you're going to do for the construction industry and the savings and so on. So thank you very much. This, as well as other interviews, can be found on drasticsummit.com. And thank you very much. Have a wonderful day.
It was a pleasure. Thank you, Steve.
Bye-bye.